A rare visitor from deep space is flying through our solar system, an object now officially named 3 Atlas. Astronomers have spotted another mysterious interstellar traveler racing across the skies, and this one is mind-blowingly huge. Dubbed 3I/Atlas, it is hurtling along at more than 150,000 miles per hour and may stretch up to 12 miles across, far dwarfing its predecessor, Oumuamua. Telescopes around the world are scrambling to study its strange glow, its puzzling trajectory, and the ghostly haze that surrounds it. Some scientists wonder if it is simply a frozen rock, while others speculate it could be something far more extraordinary. Could this colossal wanderer from another star hold secrets that redefine what we know about the universe? The breaking discovery came in the night skies of late June 2025, when astronomers detected a mysterious object streaking through our solar system at an astonishing pace. This was not just another comet or asteroid. Instead, it became clear that the object had come from beyond our solar system, making it only the third confirmed interstellar object ever discovered. Officially designated 3I/Atlas, the find has electrified the astronomical community. At first, its appearance in telescope data left astronomers puzzled. Was it a comet, an asteroid, or something entirely new? As observations mounted, one fact became undeniable. This object wasn't from around here. What makes the discovery so remarkable is the rarity of such interstellar visitors. For centuries, scientists have cataloged thousands of asteroids and comets bound to the Sun, yet not a single interstellar object had been confirmed before 2017. Now, in less than a decade, 3 have been spotted. This isn't just a random piece of cosmic debris drifting by. It is a messenger from another star system, carrying clues about distant worlds we may never reach ourselves. The story of how it was found, what it might be, and where it is headed reads like a cosmic detective novel, full of twists that have astronomers glued to their telescopes. As it races through our celestial neighborhood at 152,000 miles per hour, 3I/Atlas offers a rare opportunity to study material forged around another star. It is like receiving a package from a place we've never been, a scientific gift delivered across the vast emptiness between the stars. The discovery story began on what seemed like an ordinary night between June 25th and June 29th, 2025. The Atlas system, short for Asteroid Terrestrial Impact Last Alert System, was performing its routine scans of the night sky, searching for objects that might pose a danger to Earth. With powerful telescopes in Hawaii and South Africa, this automated guardian watches over the planet day and night. And on this occasion, it found the unexpected. And unexpected is exactly what it found. At first, the object appeared as nothing more than a faint, sliding across the backdrop of stars. The Atlas system flagged it as interesting, but nothing extraordinary, just another space rock to add to the ever-growing catalog of near-Earth objects. It was given the forgettable designation 11PL3Z, just a string of characters in the vast database of sky discoveries. Then came Tuesday, July 1st. Astronomers using a telescope in Chile noticed something unusual. The object wasn't following a normal orbital path. Its trajectory looked wrong. It was moving far too quickly, and its orbit didn't make sense if it were truly part of our solar system. Follow-up observations on July 1st and 2nd confirmed their suspicions. This wasn't another asteroid or comet tied to the Sun's gravity. It was something else entirely, an interstellar traveler just passing through. The breakthrough came from an unexpected source. Amateur astronomer Sam Dean decided to dig through older Atlas images from late June. There it was, the same faint object caught days earlier, providing precious data about its motion across the sky. This discovery allowed scientists to calculate its trajectory with far greater precision. By Wednesday evening, the Minor Planet Center, the global authority that tracks celestial objects, had logged more than 100 confirmed sightings from telescopes worldwide. Some astronomers even reported evidence of a faint coma, a ghostly haze of gas and dust surrounding the body, suggesting it might be comet-like in nature. With this growing body of data, the scientific community was ready to give the visitor an official name, 3I/Atlas. The 3i designates it as the third interstellar object ever confirmed, while Atlas honors the telescope system that first spotted it. According to Paul Chodas, director of NASA's Center for Near-Earth Object Studies, its sheer speed and orbital track leave no doubt. There's no question this came from interstellar space. If you trace its orbit backward, it appears to be arriving from the general direction of the galactic center. It definitely came from another star system. We just don't know which one. The confirmation of a third interstellar visitor in less than a decade has astronomers rethinking old assumptions. Perhaps these cosmic wanderers are not as rare as once believed. Instead, it may be that only now, with improved technology and global networks of skywatchers, humanity is finally catching sight of travelers that have been silently slipping through our cosmic neighborhood all along. A stranger in our midst. What makes 3i/Atlas stand out from the countless other objects rushing through our solar system? For one thing, its speed is mind-boggling, nearly 152,000 miles per hour. At that velocity, it could travel from Earth to the Moon in just over an hour and a half. By comparison, most objects bound by the Sun's gravity move far more slowly. Objects in our solar system usually move much slower because they are bound by the Sun's gravity. 3i/Atlas, on the other hand, is just passing through, barely influenced by our star's pull. Its incredible speed alone tells scientists that this visitor isn't from around here. When astronomers trace its path backward, it doesn't loop around the Sun like comets or asteroids do. Instead, its trajectory points outward toward deep space, suggesting it may have come from the general direction of the galactic center, though its exact star system of origin remains unknown. Then there's its unusual brightness. Harvard astronomer Avi Loeb noticed something remarkable in the data. 3i/Atlas is reflecting far more sunlight than expected for an interstellar object. This observation leaves two possibilities. Either it has a highly reflective surface, or it's simply enormous. If its surface is dark, like most asteroids, then the object would need to be nearly 12 miles, 20 kilometers, wide to account for its brightness. That would make it massive compared to our previous interstellar visitors. Oumuamua, estimated at about 100 meters long, and Comet Borisov, roughly 400 meters across. If these size estimates prove correct, 3i/Atlas could be dozens of times larger than either of them. Another intriguing feature is its comet-like behavior. Some telescopes have detected a faint coma, a thin haze of gas and dust surrounding the object. This suggests that 3i/Atlas may indeed be a comet, though quite different from the ones we know in our solar system. As it moves closer to the Sun and heats up, astronomers expect it may develop a more visible tail, which could offer new clues about its composition. Its orbit is also highly unusual. Most objects in our solar system orbit along the same flat plane, like pieces on a spinning disk with the Sun at the center. But 3i/Atlas is cutting through this disk at a steep angle, further confirming that it did not form alongside our planets. The more astronomers study it, the clearer it becomes that this is no ordinary space rock. It is a time capsule from another star system, carrying secrets about worlds far beyond our reach. With each new observation, telescopes reveal more about the nature of this cosmic messenger and about the universe beyond our Sun. The predecessors. To fully appreciate why 3i/Atlas has scientists so excited, it helps to look back at the short but groundbreaking history of interstellar object discoveries. Before 2017, humanity had never confirmed a single visitor from outside our solar system. For all of recorded history, everything we observed belonged to our own cosmic neighborhood. That changed on October 19, 2017, when Hawaiian astronomers using the Pan-STARRS telescope spotted something extraordinary. The object, later named Oumuamua, meaning scout, or messenger from afar in Hawaiian, was unlike anything seen before. Its shape appeared bizarre, either long and cigar-like or perhaps thin and pancake-flat, depending on the interpretation. It was tumbling through space, reflecting sunlight in a way that made its brightness vary dramatically. What really puzzled scientists about Oumuamua was its acceleration as it left our solar system. Strangely, it sped up slightly, which isn't what gravity alone would cause. Normally, objects slow down as they move farther from the sun's pull. This unexpected acceleration sparked intense debate. Some scientists suggested it was outgassing, releasing invisible gas that acted like a subtle rocket engine. Others, including Harvard's Avi Loeb, proposed more exotic explanations, even raising the possibility that it could be an alien light sail or a spacecraft. Unfortunately, Oumuamua left our solar system quickly, before we could get a good look with our most powerful telescopes. It left behind more questions than answers. Then came our second interstellar visitor, discovered in August 2019 by amateur astronomer Gennady Borisov. Unlike the mysterious Oumuamua, this object, named Comet 2I/Borisov in his honor, was unmistakably a comet. It had a visible tail and behaved much like comets in our own solar system. Borisov was also easier to study, since it was spotted months before its closest approach to the Sun. Scientists determined it was about 400 meters across and composed of materials similar to those found in comets from our outer solar system. This similarity was intriguing, as it suggested that comet formation might be a universal process occurring across different star systems. These two visitors were tantalizing glimpses of objects from beyond our solar system, but their differences raised many questions. Oumuamua didn't look or act like anything we had ever seen before, while Borisov seemed remarkably familiar. Now, with 3I/Atlas, we have a third data point that may help us understand what's normal and what's unusual about these cosmic wanderers. The rapid succession of these discoveries, 3 in less than a decade after centuries of seeing none, has made scientists wonder if interstellar objects are actually much more common than once thought. Perhaps they have been passing through all along and we simply lacked the technology to detect them until recently. Let's follow 3I/Atlas on its remarkable journey through our solar system. As of early July 2025, it is zooming through space at over 152,000 miles per hour. Currently, it sits about 3.8 times farther from the Sun than Earth is beyond the orbit of Mars, but still well within the asteroid belt. Unlike objects that belong to our solar system, 3I/Atlas isn't circling the Sun. Instead, it's on what astronomers call a hyperbolic trajectory, essentially a one-way path that will take it through our system and then back out into interstellar space, never to return. If we could trace its path backward through space and time, it would lead us toward the galactic center. The object's trajectory points back toward the center of the Milky Way galaxy. However, pinpointing its exact star of origin is practically impossible. Space is vast, and during the millions of years it may have traveled, even stars themselves have shifted positions. It's like trying to trace a single raindrop back to the cloud it came from. The connections have been lost to both time and distance. Looking ahead, 3I/Atlas has some intriguing encounters on its journey. On October 3, 2025, it will make its closest approach to Mars. This will mark the first time it passes near one of our planets, giving astronomers the opportunity to observe how the planet's gravity may slightly alter its path. Then, on October 23, 2025, the object will reach perihelion, its closest point to the Sun. Even then, it will remain about twice as far from the Sun as Earth is. This distance is important for two reasons. First, it ensures the object will not be intensely heated by the Sun, sparing it from breaking apart if it is a fragile comet. Second, it confirms that 3I/Atlas poses absolutely no threat to Earth. In fact, when the object reaches perihelion, Earth will be on the opposite side of the Sun. The closest it will come to our planet is in December 2025, and even then, it will remain at a very safe distance. After that encounter, the interstellar traveler will continue its long journey back into deep space, gradually accelerating as it escapes the Sun's gravitational grip. What makes this journey fascinating is that 3I/Atlas is essentially a tourist in our solar system, a brief visitor passing through on an eternal voyage across the galaxy. Formed around another star perhaps billions of years ago, it has likely been drifting through the empty void of interstellar space for millions of years before arriving, by chance, in our cosmic neighborhood. And just as suddenly as it appeared, it will leave again, carrying with it the silent record of its encounter with our Sun and planets. That record will remain unread, unless someday it happens to pass through another star system inhabited by beings capable of detecting it. The discovery of 3I/Atlas is far more than just an astronomical curiosity. It is a scientific gold mine, an opportunity that could revolutionize our understanding of how planetary systems form throughout the galaxy. Until recently, the only planetary system we could study up close was our own. Everything we knew about planet formation, asteroid composition, and comet behavior came from objects born around our sun. Now, with 3I/Atlas, we have a genuine fragment from another star system passing right through our backyard. It's like picking up a rock from Mars without having to send a spacecraft there, a priceless scientific gift delivered straight across the stars. The discovery of 3I/Atlas gives scientists a rare opportunity to study material that formed under conditions entirely different from those in our early solar system. What makes this chance even more valuable is the object's apparent size. Unlike our previous interstellar visitors, 3I/Atlas seems significantly larger, which means astronomers can collect better observations, capture more detailed spectra, and potentially determine its composition with far greater accuracy than was possible with either Oumuamua or Borisov. If it is indeed a comet, as early observations suggest, it offers a remarkable opportunity to compare its ice, dust, and gas content with comets from our own system. Questions arise. Are the same chemicals present? Are they in similar proportions? The answers could help determine whether the ingredients for life, as we know it, are common throughout the galaxy, or if they are unique to our corner of space. Another exciting aspect of this discovery is timing. Unlike Oumuamua, which was already leaving the solar system by the time it was spotted, 3I/Atlas was detected relatively early in its journey. That gives astronomers months to study it as it approaches the Sun, reaches perihelion, and then departs into deep space. This extended window allows researchers to coordinate observations using different telescopes and instruments, both on Earth and in orbit. The timing is fortunate for another reason as well. When Oumuamua passed through in 2017, the James Webb Space Telescope had not yet been launched. Now, with Webb fully operational, along with other advanced observatories, scientists have unprecedented tools to analyze this interstellar visitor in exquisite detail. Perhaps the most profound implication of these discoveries is what they reveal about the frequency of interstellar visitors. Before Oumuamua, many scientists believed we might detect such an object once every few decades. But with 3 confirmed in less than a decade, those estimates are being dramatically revised. It now seems likely that interstellar objects pass through our solar system far more often than once thought, perhaps multiple times each year. Most, however, escape notice because they are too small or pass too far from Earth to be detected. If these visitors are indeed common, it suggests that planetary systems throughout the galaxy routinely eject material into interstellar space. That, in turn, sheds light on how solar systems evolve and interact across vast distances and timescales. Still, despite our advanced technology, 3I/Atlas guards many secrets. One of the greatest mysteries is its exact nature. Is it truly a comet, an asteroid, or something that doesn't fit into any of our familiar categories? Early observations reveal hints of cometary behavior, a faint, fuzzy appearance that suggests gas and dust may be escaping from its surface as it warms in the sunlight. Yet the details remain unclear, leaving astronomers with more questions than answers. As 3I/Atlas warms under the sun's rays, astronomers have noticed signs of comet-like activity, but without the dramatic tail we usually associate with comets. Some researchers suggest it could be a pristine comet, one that has never before passed close to a star and still retains its original ice and volatile materials. Another puzzle lies in its unusual brightness. Harvard astronomer Avi Loeb has pointed out that 3I/Atlas reflects more light than expected. If its surface is dark, like most asteroids, it would need to be enormous, about 12 miles, 20 kilometers across, to appear this bright. However, if its surface is unusually reflective, the object could be much smaller. Determining its true size and reflectivity has proven difficult, even with the most advanced telescopes. Rotation adds yet another layer of mystery. Most space objects spin in a predictable way, but measuring the rotation rate of 3I/Atlas has been challenging. Some observations hint that it may be tumbling chaotically instead of rotating smoothly along a single axis. If this is confirmed, it could point to a violent past, perhaps a collision with another body or a close encounter with a massive object that disrupted its spin. Then there is the question of its age and origin. Did it form relatively recently around a nearby star, or has it been wandering the galaxy for billions of years? Its surface features and composition might hold the answers, but obtaining that level of detail requires observations beyond what has yet been achieved. Perhaps the most tantalizing mystery is what 3I/Atlas might reveal about the star system it came from. Every planetary system leaves a unique fingerprint on the objects that form within it, encoded in the ratios of elements, specific minerals, and isotopic compositions. If astronomers can decode these clues, they might learn about a distant planetary system we could never hope to visit directly. Researchers are also keeping a close watch for signs of non-gravitational acceleration as the object travels through our system. When Oumuamua exhibited such behavior, it sparked intense debate, with explanations ranging from outgassing to more exotic ideas. If 3I/Atlas shows a similar effect, it may suggest that this is a common feature of interstellar visitors rather than an anomaly. These open questions make 3I/Atlas far more than just another object to catalog. It is a cosmic puzzle box, each new observation offering a potential clue about its history and nature. With several months of observation still ahead before it vanishes back into interstellar space, astronomers are eager to solve as many of these puzzles as possible. And yet, beyond the science, one question inevitably lingers in the public imagination. Could it be artificial? Could we, perhaps, be observing not just a natural interstellar wanderer, but something more? Could we be observing something made by intelligent beings from another star system? This question isn't just idle science fiction. Harvard astronomer Avi Loeb, one of the most well-known astrophysicists in the world, has been outspoken about considering such possibilities, especially after the puzzling case of Oumuamua in 2017. Loeb famously suggested that Oumuamua's unusual acceleration and elongated shape could have been consistent with an alien light sail or probe. Now, with 3I/Atlas, he has re-entered the debate, urging astronomers to use the James Webb Space Telescope to look for signs of non-gravitational acceleration, motion that cannot be explained by gravity alone. If such a force is detected, it could potentially hint at some form of artificial propulsion. But before leaping to conclusions about alien spacecraft, it is essential to remember that non-gravitational acceleration can have entirely natural explanations. Comets, for example, often display this behavior when solar heating causes surface ice to sublimate into gas. The resulting jets act like tiny rocket engines, gently nudging the comet off its predicted path. This process, called outgassing, can explain many subtle trajectory changes without invoking anything exotic. So, what would make 3I/Atlas truly suspicious from an artificial standpoint? Scientists point to several potential red flags. If the object were to change direction in a way that defies physics, if it emitted radio signals or other indicators of technology, or if its composition included elements or isotopes in combinations that cannot occur naturally. Another key clue could come from its brightness. Natural objects, with their irregular shapes, usually display fluctuating light curves as they tumble or rotate. A consistent, repeating pattern, or an unusually steady brightness, might suggest a more regular, possibly artificial, shape. The reality, however, is that while entertaining the artificial hypothesis is scientifically valid, history shows us that natural explanations almost always win out. When pulsars were first discovered in the 1960s, their astonishingly regular radio pulses led some astronomers to speculate that they might be alien beacons. Today, we know they are rapidly rotating neutron stars. Exotic, yes, but entirely natural. Still, the possibility, however remote, that interstellar objects could be technology from another civilization is part of what makes them so captivating. They force us to confront one of humanity's oldest and deepest questions. Are we alone in the universe? Even if 3I/Atlas ultimately proves to be a perfectly natural object, its journey through our solar system remains extraordinary, a fleeting encounter with a traveler from another star, and a reminder of the vast, mysterious galaxy we inhabit. Comet or asteroid, the very act of investigating all possibilities, including artificial origins, pushes our scientific understanding forward. As Carl Sagan famously reminded us, extraordinary claims require extraordinary evidence. While most astronomers consider it highly unlikely that 3I/Atlas is artificial, they remain open to any extraordinary evidence that might suggest otherwise as it continues its journey through our solar system. But how exactly do you study a dark object, possibly smaller than a city, racing at 152,000 miles per hour and billions of miles away? It takes some serious technological firepower, and fortunately, we have more of that now than ever before. Astronomers around the globe are pointing every available telescope at 3I/Atlas, joining forces in an unprecedented international effort to unlock its secrets before it vanishes from our neighborhood forever. Ground-based observatories from Hawaii to Chile to South Africa are measuring its brightness, charting its movement, and analyzing the faint light it reflects for hints about its composition. The real game changers, however, are our space-based observatories. The James Webb Space Telescope, with its massive 21.3-foot mirror and extraordinary infrared sensitivity, is perfectly suited to study objects like 3I/Atlas. Webb can detect heat signatures and identify the unique chemical fingerprints of minerals and ices on its surface. Astronomers have already secured valuable observation time to examine this interstellar traveler in detail. Hubble, though older, still contributes essential ultraviolet data that complements Webb's infrared vision. Together, these space telescopes create a more complete picture of the object across multiple wavelengths of light. Beyond simply looking, astronomers are also listening. Radio telescopes such as the Very Large Array in New Mexico and the Allen Telescope Array in California are monitoring for any unusual emissions. While no one realistically expects alien broadcasts, these observations can reveal how the object interacts with the constant stream of charged particles from the sun, known as the solar wind. As 3I/Atlas draws closer to the sun, it will brighten, and if it is indeed a comet, a tail may form, releasing gas and dust that provide even more material for scientists to analyze. This discovery may represent the dawn of a new era. For all of human history until 2017, not a single interstellar visitor had ever been confirmed. Now, in less than a decade, we've detected 3. This sudden burst is not likely due to an increase in interstellar traffic, but rather the result of improved technology. Automated surveys, sharper telescopes, and advanced software capable of spotting unusual motion patterns have transformed our ability to notice what was always there. The upcoming Vera Rubin Observatory will take this capability even further. With its enormous camera photographing the entire visible sky every few nights, it will produce a continuous movie of the heavens. Astronomers expect it could identify several interstellar objects each year, perhaps even dozens. A growing catalog of such visitors will allow scientists to tackle fundamental questions. Are most interstellar objects icy comets, rocky asteroids, or something altogether new? Do they usually originate from the outer regions of their home systems, or are they scattered out from closer in? And how often are planetary systems flinging their material into the void? The answers will reshape our picture of how planetary systems form, evolve, and interact across the galaxy. Some researchers are even pushing for spacecraft designed to intercept these visitors. Although 3I/Atlas was discovered too late for such a mission, space agencies and private companies are already sketching rapid response concepts, probes that could be launched quickly if another interstellar traveler is spotted early enough.